Alright guys, so now getting into our chapter all about translations and geometric transformations. Our first unit here, 8.1, is all talking about translations. So the first thing we want to talk about is a rigid motion. Now rigid, you should recognize as meaning like fixed or solid or not changing. But what we see here is that a rigid motion changes the location or the look of a figure without changing its side lengths. So it cannot change the size of the shape, nor can it change the angle measures. So it preserves the side lengths and the angle measures. So now look down here at these examples and think which of them are rigid motions, which are not. So either use check marks and X's or circle the ones that are rigid motions. Pause and try that on your own for a moment. So what we see here is that 3 of them are rigid motions. My first one up here is a reflection. My one right below that is a translation to the right and down. My one over here is a translation to the right and up as well as a reflection, so a lot of combined motions there. And then this one with the circles is not a rigid motion because it changes the size of the circle, and we know that if we change size, that is not a rigid motion. Alright, this part confuses a lot of people, so make sure you're paying close attention. The original figure here, the beginning figure that we start with, is actually called our pre-image, and our new figure after we do the transformation is called the image, because it's the image after whatever happened. So the pre-images and images above are examples of transformations. Now a transformation does not have to be a rigid motion, so not only up here are they rigid motions, but they're also transformations. This circle transformation is not a rigid motion, but it is a transformation. It is actually a dilation and a translation. So if we look down here, know that a transformation maps every point from the pre-image onto the image by a rule. So however JKQ gets to J prime K prime Q prime, that is from a rule, which here is just well, there's actually a reflection that happens and a slide, probably either straight up a reflection or a reflection and a translation. So the order of the points here is extremely important. My first point matches my first point, second matches second, third matches third. It is where it's been mapped to. So that tells me that N mapped to S. So N was my pre-image, S is my image. So what I'm being asked is what's the image of angle I? Well, since I matches U, then the image of angle I would be angle U, so we can write angle, and I actually put a little arc there, so we can say angle I translates to angle U, and then point D, well D being the third point, will then match up with P, so point D will translate to point P. What are pairs of corresponding sides? Well, I can go ahead and match up every pair. So I can start with NI matches SU. So go ahead and try to figure out the other 2 pairs of corresponding sides. All right, 2 of these are fairly straightforward. The other is normally what trips people up. So I take my first 2 points, match to my first 2, NI to SU. My second and third match to my second and third, so ID to UP. Then I take my third and my first, so DN or ND. And since I did ND, I think I was thinking Notre Dame, so I need to swap that around actually and put it in the right order of third then first, because over here I did third then first point. So third point and first point, that makes the line DN, and then third point and first point PS, that translates there. Again, this is where we'll trip up on homeworks and tests. We got to read carefully. Red figure is an image of the blue figure, so the blue figure is my pre-image, so this is where I start. So we want to talk about mapping, or talking about what points match. So 3 is pretty easy here. R will go to R prime, P will go to P prime, and T will go to T prime. So if we want to list out the pairs of corresponding sides, of course I'll have RP corresponding with R prime, P prime, PT corresponding with P prime, T prime, and RT corresponding with, or sorry, RT right here corresponding with R prime and T prime that side. Now try 4. 4 is more difficult, so pause the video and map those corresponding sides because it's not as easy as just calling it a prime point. Alright, so we see here that this actually is a reflection if we analyze the characteristics of the shapes and pay attention to where my flat pieces are and where my angles are at. So that actually tells me that from my original, my W, I map to the point R. So now if I want to match up these corresponding sides, I could say that GW, not George Washington, but that maps to MR. Then I could say that GB maps to, now remember order is extremely important here, so GB, G being the top point, B being the bottom, has to go top, bottom, so maps to MS. And we can keep going and list out the rest of the sides, so go ahead and do that. So then here are all of our corresponding side pairs. Should be in the right order. Always make sure that if I start at N, I would start at X, or if I start at B, I start at S. Always have to have the matching pieces. So I'm going to talk about specifically a translation, and a lot of people will get translation and transformation goofed up. A translation is a specific type of transformation. So a translation maps all points on a figure the same distance and same direction. So notice here, a translation can only move horizontally and or vertically. It can't rotate, it can't flip or reflect or dilate, which means change size. Can't do any of that. So my original point A matches my new point A, my original point C to my new point C, and same with B. So go ahead and try down here to graph the A prime, B prime, C prime triangle by translating ABC to the right 2 and then down 1. And we're going to do this by doing that rule to every single point. Pause the video now and give that a shot. So when I map everything, I get the same exact shape, just shifted to the right and down a little bit. So now we can use our function notation to describe this, because we can talk about this as saying ABC is mapped to whatever the X was. Because we went 2 to the right, my X gets added by 2, and my Y, because it's going down 1, gets subtracted by 1. So the other way that we can write this is using translation notation, which is by using a capital T to represent the translation you're going to take, and then putting a point in these fancy schmancy little brackets like this. Kind of looks like a less than and a greater than symbol. And this is the X translation, so positive 2 meaning 2 to the right, and the Y translation meaning 1 down. And that's going to happen to all of triangle ABC. Hopefully, if you've watched through the Pearson module, you then see that we can do translation of 2, -1 for each individual point. So we could do that for point A and then figure out where that's going to go, and the same for B and the same for C. So go ahead. We're going to actually erase everything on this graph, or if you want to, you can move on to the next one. But I'm going to show what are the vertices of this translation, this same original ABC, and now with a translation of 1, -4. So figure out what the 1 tells me to do, what the -4 tells me, and make that happen here. So I went ahead and color coded this. The 1 tells me to go right 1, and the -4 tells me to go down 4, since that's the Y change. So for all these points, I go to the right 1, then I go down 4, and I graph the exact same triangle, but now it's called A prime, B prime, C prime, since it is the image, and my ABC is now the pre-image. Go ahead and try that down here on the next example. So take this shape and translate with the factors 5, -1. So again, my drawing looks like a third grader thanks to my Smart tab, but this is the best I can do. Translating 5 to the right and 1 down for all of these points gets you another parallelogram, just shifted 5 right and 1 down. One really beneficial thing about translations is that we know it does the same thing to every single point. So I can just look at one point to be able to write the translation rule. So we look at where the original point L is, since we see it on the coordinate grid over here. So L is at -6, -1, so I write that out. And then I say it gets mapped to L prime, which is at, we're told, +1, -2. So having both of these points, I can look at what is my change in X and what is my change in Y. My change in x to go from -6 to +1 is a 7. And to go from -1 to -2, that takes me down by 1. So now I can write that the translation rule here would be a +7 for the x and a -1 for the y, or we could say 7 right and 1 down. So now again, one of the most common mistakes is using the wrong image or pre-image, so pay attention that red is my image, which means I'm going from the blue to the red. So go ahead, write the rule for both of these. What would be my translation rule? You can either write it using translation notation or just write out the rule. Pause the video, try those, and come back. So paying attention that we're going blue to red, no matter which point I pick here, we're going to the right 1 and down 1. So my translation, I could write translation notation as 1, -1. Now over here, you got to pay close attention that we're going from blue to red. A lot of people will try to go from red to blue because it's left to right, but you got to watch out for that trap. Going from blue to red, I like to pick the point where I could draw the translation without conflicting with the other shape. If I draw this one over here, I'm going to get in the way of the shape. Same with any of the other ones, I kind of write over top of the shape. So I use that bottom right point, and I say I have translated down by 3, so that'll be a -3, and left 4, so that'll be a -4. So if I write the translation notation, remember my x's come first, so that'd be -4, and then my y's come second, -3. Or we could write it left 4, down 3. So here again, we're being picky about what we call things. Remember, a translation is just that horizontal or vertical shift. So if I have one translation followed by another translation, we call this a composition. When you compose things, you're putting multiple things together. So a composition of translations, and that composition of translations we will actually call a transformation. So now that I've got that spelled right, this is transformation. And then how do we find a single translation rule that has the same effect as a composition of translations? Well, telling somebody to go forward and then go right is the same as telling them to go forward and to the right. So actually, a composition of translations is often just another translation. It's just a combined translation where you tell them to do both things at one time. So what we do here to combine these translations, we have a translation here that tells us to go to the right and up, so I wrote out 2 right, 5 up. This translation here then has a -4, so it tells me to go to the left 4, up 9. So now we have 2 conflicting translations. So if I went to the right 2 and then went to the left 4, really the net movement would be 2 left. And if I went up by 5 and then up by another 9, I'd really just be going 14 up. So when we combine the 2 translations together, what I really end up with is one translation that is -2, 14. And I could also just add the values, 2 plus a -4, that gives me the -2, and then 5 plus the 9, that gives me the +14. So try that on your last one here. This is the last problem for this lesson. Pause the video, give that a shot. So when I combine these 2 translations, I have a translation 12 right and 0.5 up, a translation 1 right and 3 down. So I combine these, that actually gives me a net vertical translation of 2.5 down. I have a net horizontal translation of 13 to the right. So then I write my translation rule out here, and I say that is going to be the translation affecting X and Y. That is all we have for this lesson, so please make sure you've worked through the Pearson modules, done your practice, and please let me know if you have any questions, comments, or concerns about topic 8. Thank you. Have a wonderful day.